Okay, so this is a prototype truss build. Its dimensions are actually slightly wrong because uh, I built it before doing some more modeling and finding some more optimizations. First of all, this bottom was constructed for a non-bonus tower. It should really be increased by like 2 centimeters to get 5 kilos more of weight. And this top can be shrunk by like a couple tenths of a centimeter because by rotating the loading block, you can actually make the top like stretch it up to 4.48 centimeters instead of what its current state is. The For materials, it's using balsa. It's going to use balsa wood and cyanoacrylate. Balsa wood because nothing can compete in it in terms of specific strength, and cyanoacrylate just because it's probably the lightest glue you can get for this, and it's strong enough that you can apply extremely small amounts of it with a needle. This prototype uses square balsa because the jig is still getting printed and modeled. As for what are the stress drain portions of the build, I'm assuming that's a mistake because all parts that are under stress will have strain and all parts that are under strain will have stress. I assume what was meant is what parts are under compression and tension. The main posts are obviously going to uh, be under compression. The cross bracing is probably under compression, possibly under torsion. It may have some tensile elements, but compression and torsion have relatively similar models for failure, and they're unlikely to fail in tension, considering that's what they'll be strongest at. So it should just generally be the cross bracing should generally be modeled around compression or torsion. For what the specific wood and tower dimensions, for the posts, there's not really many other choices than equilateral triangles with side length of 3/16 of an inch. That's the You can only buy it in certain thicknesses, and that's roughly where you want it. Big enough to compensate for the fewer posts. You could get slightly more than 3/16 if you're willing to add a third sanding step by carving it out in a weird tilted angle, but that probably introduces some problems with tolerances, and it's probably not worth it. For cross bracing dimensions, so we have some from last year that we can roughly scale up, probably favoring increasing cross-sectional area over increasing density. Balsa Engineering has one that held 18 kilos, and I still have the spreadsheet from last year, so we can probably go somewhere in between those, since 18 kilos, the ones for 18 kilos was too high, and the ones from last year would be too low for only a 3-pole tower. And as for what problems, everything this year will require a jig from the posts to the assembly, so there's gonna take a lot of printing jigs before we can even get stuff started. We can start modeling stuff in that time to optimize before we even start building, but it's still gonna take a while to get all the jigs, especially the one to assemble the tower. It's quite large. Also, the fewer posts means that the cross bracing will be much longer and will need to be optimized a lot further. The Since both compression and torsion have will have a stronger relationship with, well, second moment of area relation to the cross section than the Young's modulus, and the Young's modulus scales roughly linearly with the density. It's generally better to go for larger, lower density cross bracing, but you can only find so low density wood, so you sort of have to find the lowest density wood you can get and then calculate from that to see how small or big you have to make it just to get it to stand. For Yeah, the assembly this here is really going to be a problem. We're going to need a jig this year. We can't do it like last year. Okay, so we can do roughly something like from 0.10 width to 0.15 width at the bottom is last year's, and Balsa Engineering did 0.128 to 0.538. For both compression and torsion, it would be best to go for as well. There's a relationship here that we want it to be flat for better glue strength, but more square for better compression and torsion resistance. The If the glue is applied across the entire thing and evenly enough, we can probably go for more square to optimize it. The triangle cross bracing does reduce the surface area of the posts, though, so you really have to do a trade-off between the two. We'll have to go for decently flatter, like maybe somewhere between 116 and 132.